Why have I got "It's so lovely to have you"? Hold on.
It's not.
Yeah, that couldn't be further from the truth.
Hello and welcome back to Physics Chat. Physics Chat is a show where we talk to interesting people about their research and ask the question about what it's like to be a modern day physicist. You know I couldn't do this alone. Joe and Fox are back with me on the hosting panel. Hello, and how are you doing?
I'm really well, thanks, Susanna. How are you doing, Fox?
Yeah, good. I've actually had coffee this time, so better.
Oh, brilliant. Our next guest is a PhD student from the University of Missouri, Kansas City, who is researching active galactic nuclei, otherwise known as AGN. Ben is currently visiting the UK and has had to put up with me for the past 3 months, and after some nagging, has finally agreed to be on Physics Chat. So how are you doing, Ben?
Hello, I'm doing very well.
Good. So what has been the highlight of your trip to the UK so far?
Ooh, honestly, all of you guys. No, it's been great meeting a lot of other, like-minded astronomers and cosmologists and everybody, and being in kind of like a real astro department. It's been really fun.
Oh, that's such a lovely answer. But anyway, it's time for my random question. What is your favorite British food that you have tried?
You know what? Just to be kind of stereotypical, we'll say fish and chips. It's been really wonderful doing that, like at the beach and everything.
We do good fish and chips in Portsmouth. So
It's very tasty.
Right, now getting back to the actual physics at hand, could you summarize your research in one sentence, please?
Sure. I study the central supermassive black holes that are actively accreting material in galaxies that are in galaxy clusters. We want to know how the activity of those supermassive black holes affects the galaxy evolution of those galaxies in the dense environments of galaxy clusters.
Wow, okay, so we've got a lot to unpack in there. I guess we'll start with what is a galaxy cluster? We've heard from Sam Penny about what galaxies are, but what does a galaxy cluster mean?
Galaxy clusters are large collections of clusters. You may be a little bit more familiar with like a galaxy group, because that's what the Milky Way and all of its satellites, as well as Andromeda, form, is like a small collection of galaxies. Galaxy clusters are collections of galaxies that are like hundreds or thousands of galaxies in a relatively small volume. So effectively, they're like large cities of galaxies. A galaxy group would be more akin to like a smaller like town, which has maybe some suburbs or something like that. The far extreme of that would be isolated galaxy. We typically call those field galaxies. And so they're just kind of off on their own without any major like companions nearby.
Oh, okay, cool. So that's really interesting. I love hearing about how we sort of learn different things from things on different scales. So what kind of thing can we learn from galaxy clusters? Why are they interesting?
They're interesting for quite a few reasons. Because they're such dense environments, we can study a lot of galaxies in close proximity to each other. So there's more chances for, say, galaxy mergers or interactions. But more than that, galaxy clusters are really important for cosmology even, because they are the most massive gravitationally collapsed structures in the universe. They are very important to kind of tracing the evolution of matter collapsing in the universe. And so we can use them as laboratories for that, as well as there is a very dense, hot gas that envelops the galaxy cluster. We call it a intra-cluster medium. It's X-ray bright because it's so hot. And that provides a lot of like fluid dynamics that happen because of like the galaxies moving around in them, as well as the supermassive black holes, which can move a lot of material and create bubbles and cavities in this fluid. So it's very interesting structures.
Wow, yeah. So learning a lot about cosmic history sounds really important. So you mentioned there as well in the original answer about supermassive black holes. We've heard about black holes aplenty on this show, but what's special about supermassive ones?
So supermassive black holes are typically, millions of the times the mass of the sun, and even up to, I think, maybe a billion, I think is maybe some of the biggest ones. They're huge, and they live typically at the center of galaxies, almost essentially all massive galaxies will host a supermassive black hole. What's really important for them for like galaxy evolution, though, is that because of all of the gas that can come around them and form an accretion disk, they can produce a lot of light. And so that can actually heat up the entire galaxy, can warm up all of the gas in the galaxy to the point where you can't make any new stars, which is where kind of I'm very interested in them.
And so is this, you mentioned that you specifically look at AGN or active galactic nuclei. Is this like related?
Yeah, so AGN are when a supermassive black hole is actively, has material around them. And so it is accreting gas and dust into an accretion disk, which is basically the stuff that's swirling around the drain, for lack of a better word. You form this kind of structure with the supermassive black hole in the center, an accretion disk of gas and dust, which gets really, really hot. If it's particularly powerful, you can also get relativistic jets of material that are basically the stuff that can't fall into the drain, but is moving so fast that it gets ejected out. And this can carry material out for millions of light years away from the host galaxy.
Wow, brilliant. Thanks, Ben. That's really good explanations.
Are supermassive black holes like gas-eating monsters of the universe then?
Kind of. They do consume a lot of gas in the center. But one thing that I would like to maybe clear up is that supermassive black holes, or black holes in general, they don't suck material in. Things fall into black holes. They're holes. It's more like things get close enough to them, and then because of gravity, they're going to fall towards that really massive object. It's not that, oh, there's a black hole nearby. Well, it's gonna like hoover everything into it. That doesn't really happen.
Lovely answer.
So now we know what an AGN is. How do we actually observe them?
So we can observe AGN in a few different wavelengths. Some of the most popular would be X-rays. X-rays are looking at basically the accretion disk itself. It's the light that's kind of coming right off of the, like really close to the supermassive black hole. We can also look at them in radio on the far wavelength regime. And that often looks at those relativistic jets. What I'm looking at is in the infrared. Here, I'm looking at not directly at the AGN, like the inner AGN structure, but I'm looking a little bit further out where there is a torus, effectively like kind of a donut, or maybe a disk of some sort of dust that sits kind of on the outside of the AGN structure. All of that light from the inner part of the structure, from the accretion disk, heats up that dust, and then it re-radiates all that light in the infrared. And then if the host galaxy is also particularly dusty, then that dust in the host galaxy can also be heated up and re-radiate in the infrared. And so that's what I'm looking at kind of an indirect way to see the supermassive black hole structure.
So just so I've understood that answer, we can look at AGN in different wavelengths, and that tells us different things about what parts emit different radiation. But we look in specifically the infrared to find these AGN that otherwise we wouldn't see in these other spectrums.
Yeah. The infrared, because we're looking at the dust itself instead of, say, the accretion disk, X-rays are really, really great for picking up most AGN. And if you talk to certain X-ray astronomers, they will say that they pick up everything. But if the galaxy or the torus is particularly dusty, the dust is so thick that the X-rays are going to scatter off of the dust. Those the X-ray wavelengths won't pick up the AGN because all of the light that we would normally see is being scattered away. If we look in the infrared, we can pick up potentially those galaxies that have active supermassive black holes that otherwise wouldn't be picked up. If we want to understand kind of the whole picture of galaxy evolution, AGN are, I think, a very major part of that picture.
Okay, so you mentioned dust. So I assume this isn't the dust we get in our houses, something else that we form in galaxies. So could you just quickly describe what's the definition of dust that you use?
Dust is kind of, there isn't, I think, a super strong definition. Depending on who you talk to, it may mean different things. But for me, it's still not dissimilar to the dust that you would see in your house. It's small particulates. Often what I personally consider mostly dust is molecules that are called polyaromatic hydrocarbons. Especially in the infrared, if you look at a galaxy spectrum, you will see these huge dips in the spectrum. And there's these giant chunks of the spectrum that are being taken out. And those are dust. And that's partly how I'm looking for them. But yeah, they're very interesting kind of things. So yeah, most people don't consider dust to be very interesting, but for astronomers, it's actually very important.
You're dust lovers then.
Yeah.
Okay, so Ben, so bringing together some of the things we've talked about today, being galaxy clusters and AGN, how does all of that relate to your research then?
My research directly is we're essentially counting the number of AGN in the galaxy clusters. And what we're really interested in is how does that number change with the distance that the galaxy cluster is from us, or the age of the universe that we're looking at them at, as well as how massive the galaxy cluster is. Essentially, do you expect to see more AGN in high mass or very massive galaxy clusters, or do you expect to see them in low mass galaxy clusters, or maybe even potentially galaxy groups? We think, and our kind of preliminary research is pointing towards that you'll see more active galaxies in lower mass systems. And this happens most likely because we're seeing the signatures of galaxy-galaxy merging happening in those systems, which will happen more efficiently at low mass, in low mass galaxy clusters. In high mass galaxy clusters, the galaxies are moving so fast around each other that they can't efficiently merge or mix with each other. So they're kind of just going to blast right past each other. But in low mass systems, like small clusters or in galaxy groups even, they're moving kind of more slowly relative to each other. So they can actually spend more time near each other. And so then they become gravitationally bound and they can actually merge and efficiently mix their gas. But this is something that is still up for debate and still something that has not been really studied as well, partially because getting the mass for a galaxy cluster is hard. And that is why my collaboration, the South Pole Telescope collaboration, has a particularly good influence on that, because of the way that we detect our galaxy clusters is, without going into too much of the detail, essentially we find the galaxy clusters by their mass. So we get the mass of the cluster for free. That gives us a very good, clean sample of galaxy clusters across a variety of different ages in the universe or distance away from us. That lets us probe kind of the evolution of these systems, and particularly for me, how the number of AGN changes with time, as well as how does the environmental effect of how massive the cluster is can affect how many of these active galaxies that we may see.
Wow, thanks, Ben. That's great to hear about some, really on the edge research there, and hope it all gets published up soon.
That's so amazing to hear how AGN plays such a significant part in galaxy evolution. And also very interesting to hear that supermassive black holes are not giant hoovers of the universe. That was really interesting. And thank you, Ben, for being on Physics Chat. We hope you have an amazing time in the UK and eat lots more fish and chips. Oh yeah, Joe, what is your favourite British food?
So I know I don't sound like it, but I'm from Yorkshire. So I'm going to go with the humble Yorkshire pudding, which is not just for savoury. You can have it with jam as a dessert as well. So there you go. What about you, Fox?
Well, I just learnt about jam Yorkshire puddings. I want to immediately try that. But no, my favourite is roast pork with some crackling. You can't beat a good bit of roast pork to me. What about you, Susanna?
I love gammon, chips, eggs, and baked beans. I love baked beans. Let us know in the comments section what your favourite British food is. We'd love to hear from you. But for now, from everyone at Field of View, we hope you have an incredible day and goodbye. Bye.
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 Even more housing. Yes.
Most people don't consider dust to be very interesting.
Wow, that was a superb, awesome, first-rate interview. It has been so ace hearing about your marvelous research and how it plans to make a tremendous impact. Just so the audience knows, I have been told to vary my reactions, or for the technical among us, positive adjectives.